We covered the basics of error handling in the first section of this course in lesson 1.28. In this lesson, we'll expand on that and talk about the exceptions, which are the OOP way of handling errors. Before we get started, if you enjoy my lessons and have not yet subscribed, please consider subscribing to ensure that you don't miss any of the new videos. So what is an exception? An exception is simply an object of some exception class that describes an error. It disrupts the normal flow of the code execution. Exceptions in PHP can be thrown manually using the throw keyword, or it can be a result of some sort of error in the PHP, whether it's coming from built-in PHP's functions, classes, or coming from your own code. You can only throw exceptions if the instance of the thrown object is either an exception class or the instance of the throwable interface. Let's look at an example. I have this invoice class here as well as the customer class. The invoice class uses property promotion in the constructor, which accepts the customer object, and has a single method called process, which accepts amount argument. Then we're simply simulating the processing of the invoice here. The customer object itself has a single promoted property called billing info, and then we have a getter method for the billing info property. Now let's say that we did not want to allow invoices to be processed if the given amount was less than or equal to 0. And also maybe we didn't want to allow invoices to be processed if the customer was missing billing information like billing address or billing name. This is where throwing exceptions could come in handy. Even though you could add that validation higher up, maybe in controller or somewhere else, it is always a good idea to do it in the low level so that you can be sure that anywhere where the process method is used, you're not allowing certain invoices to be processed based on the conditions. So here we can do something like this. If amount is less than or equal to 0, then we can use the throw keyword followed by the new keyword, and we can throw one of the built-in exceptions. There is a base exception class called exception, so we can throw that for now, which will simply throw a generic exception. Let's provide some generic message here, something like invalid invoice amount. Now, of course, we should not be comparing floats directly for equality, but for this example, I'm just going to keep it simple and just keep it as is. And we covered why you shouldn't compare floats directly for equality in the first section of the course within the lesson about the floats data type. So let's run the code and test this out. And so far, everything is working because we are passing in the 25 as the amount, and it is not less than or equal to 0, and therefore everything is working. Now let's pass in negative 25 and let's run the code again. And sure enough, we're getting this exception thrown with the error message that we specified. Now the thing is that this exception class here is very generic. We can be more specific about our exception. Before we do that though, let's take a look at what the exception class offers. So we have the message, the code, the file where the error happened, the line number. It contains the clone method, which is set to final, meaning that you cannot clone exception objects. We have a constructor that accepts message, code, and the previous exception, which enables us to link exceptions to each other. Then we also have some final methods here, which means that you cannot override these methods when you're extending exception class. Now, if we scroll a little bit more down here, we see this error class that implements throwable. If we scroll up to the exception class, we see that it also implements throwable. Essentially, both exception class and error class are types of exceptions that implement throwable interface. Exception is the base class for all exceptions that can include user-defined exceptions as well, while error class is the base class for PHP's internal error exceptions since PHP 7. Both the exception class and the error class implement throwable interface, which allow us to catch both exceptions and errors using the throwable interface. And we'll talk about this more in a few minutes. Now, as I mentioned before, PHP has some built-in exceptions that are more specific. For example, what are we trying to do here? We are throwing an exception because the given argument is invalid, right? Just so it happens, PHP has a built-in exception called invalid argument exception, and it makes sense in this case because the given argument is invalid. Now, if we run the code, it still throws an exception, but it throws invalid argument exception. If we click into that, we see that it's just a regular class that simply extends logic exception. And if we click into the logic exception, it's just another class that extends exception. So essentially, all exceptions are based off of the exception class unless they're PHP's internal errors. We can do the same if the billing information is missing. So we can check if the billing info is empty, and if it is, we can simply throw invalid argument exception. The thing is though, the invalid argument exception in this case does not really make sense because the given argument, which is the amount, is valid, because if we get to this section, that means that this section passed here and the given argument is valid. The issue is with the customer object and its content. We can try to use one of the available exceptions exceptions that standard PHP library or SPL offers. And if we can't find any suitable built-in exception, then we can always throw the base exception class. So instead of invalid argument exception, we can simply throw the base exception class, or we can simply throw logic exception. But this does not really tell us much about the exception, right? And if we just throw the base exception class, it's even worse because we're just throwing the base exception class without any additional information other than the error message. So it's better to be specific. If you find yourself needing to throw the base exception class and you cannot find a suitable built-in exception, then you could always create custom exception classes and extend the functionality of either the base exception class or one of the built-in exception classes. So let's see what kind of custom exception would make more sense in here. We can simply call our custom exception something like missing billing info exception, and let's create that class. And let's create that class within the app exception namespace. And as mentioned before, we cannot throw objects of classes that are not instances of the base exception class or the throwable interface. So if we go back to the invoice here, we see that ID is underlining it here, letting us know that the thrown object must be an instance of the exception or the throwable interface. So we need to simply extend the base exception class here, and we can get rid of the constructor because we could use the constructor of the base exception class. Now if we go back here, we see that the underlining is gone, and let's test this out. If I go back to index.php, let's pass in the valid amount and we run the code, and we see that now we're getting missing billing info exception. Now if we needed to throw this exception from somewhere else in the code, we would kind of need to repeat this error message over and over again. So we would need to take this and paste it into the other sections of the code where we might want to throw this exception. Now because we have the custom exception class, we can simply move this default error message within the custom exception class itself, and therefore avoid the duplication of the error message. So we can take this and we can simply override the message property here and set it to the missing billing information. And now if we run the code, everything is still working. When an exception is thrown and there is no catch block, the exception will bubble up the call stack to the original calling function until it finds the matching catch block. If no catch block is found, then it will look for the global exception handler, and if that's not set, then it will simply stop execution with the fatal error. So I mentioned a few keywords here. I mentioned the catch block and I also mentioned the global exception handler, and we'll talk about the both. Notice in the exception message here, it says uncaught missing billing info exception. This means that exceptions can be caught using the try catch block. So we can add the try catch block wherever the process method is called from. So we can do something like this: try to process this invoice and then catch the exception. A try block must have at least one catch block, or it must have a finally block, and finally block simply gets called every time regardless if an exception was thrown or not. The catch block is what allows you to have your script continue working unless an exception is thrown from within the catch block itself. You can gracefully handle the exception in the catch block by maybe logging the exception somewhere and then allow the script to continue, or you can simply log the exception and rethrow the same exception, or throw a different type of exception, and so on. As you notice, the catch block simply gets the exception object in here, and this exception object can be used to get information about the error. So we can simply echo out the get message, and these are the methods that we looked at before, and we can simply get the file and get the line. Let's clear this out, run the code, and we see that we get the exception message along with the file where the error happened and the line number. Something to note about the catch block is that this variable here was required prior to PHP 8, but if you don't make use of that variable, you don't really need to have it since PHP 8. Just exception class is enough. So maybe you're not doing anything and you simply want to catch that exception and do something else, and you don't really interact with that exception object. Prior to PHP 8, you still have to have this, but since PHP 8, you can simply get rid of it and everything will still work. You can also have multiple catch blocks to catch different types of exceptions and handle them differently. So for example, the process method throws two different types of exceptions, right? We're throwing invalid argument and missing billing information exception. If we passed in invalid amount, then this is not going to be caught. So if we run the code, we see that exception was thrown. We can simply catch that exception as well and simply echo out invalid argument exception. And let's add some line breaks here and run the code. And we see that now exception is caught. Something to note about multiple catch blocks is that the code execution will continue after the first catch block that gets executed unless the catch block itself throws an exception. So for example, if we threw an invalid argument exception from within the missing billing info exception catch block, you might think that the second catch block would catch the invalid argument exception. It is not going to catch that exception because as soon as the first catch block is executed, it will simply continue the code execution, or when the exception is thrown within the catch block, it's going to bubble up in the stack, so you would need to add another try catch block higher up in the stack if you wanted to catch that exception. Now, if the handling of the both types of exceptions are the same, then you could simply catch them within the same line using the pipe character, which will simply indicate that you're catching multiple types of exceptions and handling them the same way. So we can do it this way and get rid of this catch block from here. And if we run the code, it still catches the invalid argument exception, and if we pass in the valid amount, it catches the missing billing info exception. Let's bring the variable back here and simply echo out message and run the code again, and we see that we're catching the missing billing information exception. Because both of these exceptions extend from the base exception class, you could actually catch all kinds of exceptions using the exception class, and this will still work. And now we will catch both invalid argument as well as missing billing info exception, but we can also catch other types of exceptions that extend from the exception class. If you wanted to execute some code regardless if the exception was thrown or not, this is where you could add a finally block. So we could define finally here, and let's echo something here indicating that finally block was reached. Let's run the code, and we see that finally block gets printed whenever exception is thrown. If exception is not thrown, let's pass in some billing information here and run the code. We see that the invoice was processed successfully, no exception was thrown, but the finally block was still executed. So as you can see, finally block will execute regardless if the exception was thrown or not. Something to know about the finally block is that if you have a return statement within the try or catch blocks, it will return the value after the finally block is executed. However, if you have the return statement within the finally block, then both return statements will be executed, but the value will be returned from the finally block. Let's see an example. Let's move this block of code into a function called process, and then let's return true within the try block indicating that invoice was successfully processed, and return false within the catch block indicating that it failed. Let's call this process method from here and var dump the return value of that. Let's run the code, and sure enough, the finally block is still executed even when we're returning from the try block, and we see that the boolean true was returned. Let's now trigger an exception, so the return statement from the catch block should be executed. Let's change the amount to -25, which should trigger the exception. Let's run the code, and sure enough, the finally block is still executed and boolean false is returned. Let's add the return statement in the finally block, and let's return -1 and run the code. We see that now returned value is -1 and not false, even though the catch block was also executed. So to summarize, what's happening here is that the return statement from either the try or the catch block is executed, but the value is only returned after the finally block is executed. And if the finally block also returns a value, then the value from the finally block's return statement will be returned instead of the value from try or catch block's return statements. Note that the return statement of the catch block in this case is still executed. It's just the value of the finally's return statement that is returned. We can prove that by simply calling some function within the return statement. Let's add a function called foo that simply prints foo and returns false. Let's run the code, and sure enough, we see that foo is printed, but -1 is what is returned because that is what's returned from the finally block. So to sum this up, what happens when exception is thrown is that it will bubble up the call stack until it finds the matching catch block. It will execute all the finally blocks along the way, and if the exception is not caught, then it will execute the global exception handler if it's set. If the exception handler is not set, then it will simply result in a fatal error. So let's talk about the global exception handler next. You can register global exception handler by using setExceptionHandler function, which takes a function name, callback, or a closure as an argument. This function here gets a single argument, which is simply an object of exception that is being thrown, and we're type hinting this object with the throwable interface. And the reason for that is because not all exceptions extend than the base exception class. Exceptions have existed in PHP since version 5, however it was pretty weak and PHP was generating its own internal errors without exceptions. This means that you were not able to catch such errors like you could catch exceptions and then handle them specific ways. You had to define custom error handlers. PHP 7 and PHP 8 changed the way errors are reported. Most errors are now reported by throwing the error exceptions. So we have two types of exceptions. We have the regular exceptions that can be user-defined or built-in PHP exceptions, and we have error exceptions. Before we continue with the exception handler, let's look at the hierarchy of the exceptions in the PHP. So as you can see, we have the throwable interface all the way on the top, and then we have error class and exception class. And exception class is what's being extended from the custom exceptions that we create or from the built-in exceptions that standard PHP library offers. The error class here is the base class for some of the built-in errors like the type error or the value error or the division by zero error, which is the child of the arithmetic error, and that is the child of the error class. Now when we catch exceptions and we type hint the exception class there, it will only catch those type of exceptions and it's not going to catch any of these errors. And same applies to this exception handler. That's why we're type hinting it to be throwable and not exception. Prior to PHP 7, this would be the right way to do it, but since PHP 7, this will no longer catch the type errors or any of the built-in PHP errors, therefore we need to use the throwable. And we can easily test that. We can simply use one of the PHP's built-in functions called array_rand, which simply picks the random keys from the array. And let's pass in an empty array and let's pick one random key. Let's simply echo this out and run the code. As you can see, the exception handler is not catching this error because it is throwing a value error here and we are type hinting it to be exception. Even if we added try catch around it and we run the code, we see that it still does not catch it. However, we can change this to value error and then we run the code again. We see that now it's able to catch it. We're getting this error message here saying that argument number 1 cannot be empty. Now you probably will never see somebody catching value error like this. Instead, you would see somebody catching all types of errors using throwable. So if we run the code now, we see that it still catches it. So that is the reason why, since PHP 7, the type hint of this exception object in the exception handler needs to be throwable and not exception. So we change this to throwable and we get rid of the try catch block from here and we run the code and we see that now the exception handler is able to catch that error. The exception handler function is actually pretty useful if you want to provide some kind of global exception handling. Also, just to note that PHP 8 changed the way some of the errors are reported in PHP. For example, this line here prior to PHP 8 would simply result in warning, but since PHP 8 it results in value error exception. So a lot of the internal warnings or errors that were triggered by PHP prior to PHP 8 are now triggering exceptions instead, which is a good thing because prior to PHP 8 you would not be able to catch such errors using try catch blocks, and now you can. So at this point you might be asking, can't you simply return some default values instead of throwing exceptions? Why would I want to throw exceptions within the invoice class right here? Can't we simply just use the return statement to return something and maybe log some message somewhere in the logging storage? The answer is yes, you can do that, and it's fine to do it if such cases are kind of expected. If you're expecting that amount can be 0 or less than 0 and you're expecting it to be okay, then sure, you can simply have the return statement and log whatever needs to be logged and have the handling be deferred to somewhere else in the code. However, if this is an exceptional behavior and you should not be able to continue with the code execution if the amount is invalid, then exception should be thrown. So that's what you should be looking out for when deciding whether you should throw an exception or not. If it's an exceptional behavior, then you should definitely throw an exception. If it's something that's allowed and expected, then you could simply use a return statement or do something else. Before we wrap this up, I want to show you another example of exceptions that you might come across in some frameworks or code bases. You might see some custom exception classes with static methods that act as factories kind of to create objects of exceptions. For example, instead of using the new keyword here, you might see somebody do something like this: custom exception missing billing info. And this is actually pretty common practice. One reason why that's useful is when you don't want to be too specific about your custom exceptions. For example, before this we were being very specific, right? We're throwing missing billing info exception, and that's being very specific. And it has the error message hard-coded, which is perfectly fine, but in some cases you might want to have a generic exception that is related to your domain, or in this case to invoices. So you could have a class called invoice exception, and we don't want to pass in the error message here stating that it's missing billing info, because we're going to go back to the same problem where we would be duplicating the error message. Instead of doing that, we can introduce static methods. So instead of the new keyword, we can simply throw the return value of a method called missing billing info. And now we can create this class and extend the base exception class, and we can simply add this method, and we can simply return the new object using the static keyword. And here we can hard code the error message saying that missing billing info. Now if we run the code, we see that everything is still working. It's throwing invoice exception with missing billing info message. We can go even further, and instead of throwing invalid argument exception here, we can add another method to the invoice exception and throw that instead. We can simply throw the return value of the invalid amount method on the invoice exception class. So we can add this method, and we can do the same thing here, return new static and put that error message there. And now if we go back to the index.php and provide the invalid amount and run the code, we see that everything is still working. It's throwing invoice exception with the proper error message. So either way is fine. If you want to be more specific, you can be more specific and define custom exceptions, or you can go this route where you define a generic exception that's related to your specific domain or a specific class like invoice in this case, and then provide static methods to simply generate those exceptions with the hard-coded messages. That way you're not repeating those messages. This is it for this video. Hope you enjoyed it. Thank you so much for watching. Please give this video a thumbs up, share, and subscribe, and I'll see you on the next one.